It's Mark Keane here, and with me I'm joined by...
Stefan Bitter.
Hey Steph.
How you going?
So we're here at Microsoft The North Ride again for part 2 of the Express Route Demystified video. So Steph,
Hi.
can you tell us all about like a...
Express Route.
Express Route, like a recap
How long
on
do you
the
have?
first one?
Okay,
as long as you want.
Let's see. So in part 1 of the video, and I'm sure Mark will be putting a nice little link on the on this video, we spoke about quite a few things.
We did.
So the first thing that we spoke about, and I'm going to go run very quickly, so refer to the video, please. The first thing we spoke about was Microsoft peering, public peering, private peering, how public peering is completely disappearing. It's all now under the Microsoft peering banner versus private peering. Private peering, simples, you have a private network into Azure, you have your private network on premises, you connect the both of them with ExpressRoute together. Easy. Microsoft peering, it's the public side of things. So to access all the public features within Azure, SQL as a service, storage, etc., you need Microsoft peering, which is public peering, was public peering. So with that, there's a few new things that came into play. And the main one which people get tripped on quite often is the new NAT. Microsoft used to do the NATing for you. And for those of you who don't know what NAT is, Network Address Translation, it's effectively making a translation between your private IP addresses on premises, the 10.000 and the like, to a public internet accessible IP address.
Mm-hmm.
So in the past, Microsoft was doing their own NATing. So you could do whatever you want in the background. Microsoft would slap a Microsoft IP address in the front of it, public IP address. Now with the new Microsoft peering, which replaced public peering, it's no longer the case. You have to do your own NATing, which means you have to advertise a set of your own public IP addresses in addition to the BGP peering IP addresses that is necessary to establish an ExpressRoute circuit. Now, if you want more detail about that, check out video number 1, because it's all explained in there, but it's very important to understand that you will need 3 set of public IP address, 3 prefixes, 3 range to actually get Microsoft peering going.
That was a great diagram, by the way.
Thank you. 2 for the, and we'll redraw it probably at some point today. 2 for the BGP peerings, primary, secondary, and 1 to advertise to do that NATing, that all important NATing. Okay? Now, we've had a few questions, I think, for you, Mark, about .1Q versus Q in Q.
Yeah, all buzzwords for Express Route.
That's exactly right. Yep. So, effectively, when you establish your ExpressRoute circuits, it's a layer 2 circuit, right? Which go or don't go via direct or indirect provider. We'll come to that later. So, when you do that, there's 2 methodologies really to establish that layer 2 circuit. .1Q, which is VLANs. For those of you who are in the switching world, everybody knows what a VLAN is. It's effectively segregated physical switch into multiple virtual switches. That's what a VLAN is, really.
Which is like a C tag, and the word C stands for customer.
Right. That's right. So a C tag is really a definition, a word that was invented by Microsoft in terms of ExpressRoute to determine, to show you what the different tagging is. And when we talk about tagging, this is how a VLAN works. A packet leaves the switch and gets tagged with an ID, and this ID has to be between 1 and 4096, 4090X. Anyway,
except if it's an S tag, which is massively long.
So VLANs tagging. .1Q is exactly that. So when you establish your connection with your provider, if you use .1Q, you will use a VLAN tag, C tag. At that point,
Question, and this is it's not on the board here, but just one question that sort of comes up a lot in my experience is: imagine a provider has a layer 2 switch, right, and then they've got multiple ports. So you're coming through your provider, you're plugged in layer 1, layer 2, or crossing to their switch. They've got their ports.
You land on a VLAN on their ports.
Yeah, and so their ports are configured. Now, just refresh my memory, the difference in ports. You can have a port that accepts any VLAN ID, or you can have a port that's actually already tagged as a certain VLAN.
That's right.
There's different terminologies for it.
Trunks versus not trunk.
Right.
So you can have a port on a switch, and I'm not specifically talking be part of a VLAN, which is an access port, or the port can be a trunk, which means it can access multiple VLANs. Right, so one VLAN, multiple VLANs. If you have a switch here that is one VLAN and you connect the two together, that's just a plain connection. If on the other hand, you say, I have a trunk on this side and a trunk on that side, you need to enable...
The trunk's expecting a VLAN header to come through.
That's right. So the trunk is expecting a tag,
right.
a VLAN tagging, and that tagging is .1Q.
Gotcha.
Which is the industry standards to tag packets. As they leave the port here, the packet will get tagged with an ID number 2. When it comes back here, it's going to be stripped off of the ID and sent out to the appropriate VLAN, VLAN 2.
Cool.
That's .1Q.
Nice.
So if you use .1Q for your express route circuit, which you can, it means that you and your supplier will define together what that ID is. And you'll have to talk to them because they will have a limited supply on number of IDs they can provide, of course. And it has to be the same ID on both sides, right? Once that ID is associated with your customer, with me as a customer, that ID cannot be assigned to any other customer.
Yep.
That's .1Q. Now, very quickly, because we've got quite a watch list here. When we talk about Q in Q, think about this tag when it leaves the switch. Now think about it this way. If in between here, instead of having a direct connection, I have a transit network. Transit network, meaning it's going to go through another supplier in the background. If you want to use .1Q, you now have to identify this ID, tell the ID to the transit network, and also define the ID on the endpoint, right? It's a bit of a nightmare because as a transit network, it would mean that the maximum customer I can put on that core network is 4090X, 4096, I think. So that's limitation. So to expand that, they've introduced Q in Q, which means as it leaves your router, you're going to get a tag for your VLAN, and you're going to get an additional tag for the transit network, which is going to get added when it enters and stripped out when it leaves. So the packets on either side are going to be exactly the same as they were, except that now to transit the network, they're going to get encapsulated again with a VLAN tagging inside of the transit network, right? That's what Q in Q, .1Q, Q in Q.
Or double tag VLANs.
Double tag VLANs, exactly.
Cool.
It's a tag within a tag.
Cool.
Think of it this way. That's that. Now, ASN numbers, another buzzwords that you'll hear a lot around. Now, express route requires BGP. So we're now going one layer above, layer 3. Once your layer 2 connection is established, you need somehow to forward IP packets on that. If you need to forward IP packets, you need routing. And the routing mechanism, the routing protocol that is being used to send back routes back and forth between routers is BGP, Border Gateway Protocol. Now, BGP, the way it works, and I don't know if I described that in the other video, but I'll just quickly go through it. Quick recap. So BGP is one of the biggest protocol used on the internet at the moment for all the routing. Think of it this way. Think of it as a routing domain. It's the wrong terminology, but think of it as a routing domain. You have edge routers onto that domain. This domain can all talk to each other. So pretend that in between here there's routers that talk to each other and they're fully meshed, and there you go, and they talk and they talk and they talk. This is a core network. You got your edge routers on that core network. This would be considered as a AS, stands for Autonomous System. For BGP, this means that to reach one AS and to go to another AS, you need routing. And this is where BGP comes in, whereby you establish a peer between two edge routers. You tell this edge router that, hey, if you want anything that is located in this AS number 92, I'm just making that up, and I'm 93, then you should talk to this neighbor and send your packets across there.
Gotcha.
Right? Now, this neighbor will have, say for example, you've got more routers here, and you've got plenty of networking there. So for example, here you might have a network 103.0.0.0/8, and in here you might have a 103.1.1.0/24, and here you might have a 104.0.0.0/8. With BGP, I associate this network to this AS number. So AS number, ASN, Autonomous System Number. And I publish that, effectively advertise that, to use the right terminology, from this router to this router. Now this router now knows if I need to reach 104.0.0/8, this is the AS I need to go to, this is the neighbor I need to go to. And the opposite is true too. Yep. So
Cool. Who needs Wikipedia when we got that?
Oh, I tell you what, beautiful. Okay, so that's AS numbers for you. BGP.
With a long list.
I know we do. We gotta go. Now, very quickly, how does this relate to express routes? Now we need to do private and when you do private and public peering, private and Microsoft peering. I need to get the new terminology right. You need to advertise through BGP, which means you need AS numbers. When it comes down to private peering, you can use private ASN number. In the same way as IP addresses are public versus private, you can use a private ASN, which is 65,000 something and above, right? If you do public, you need to use a public ASN, so you need to register yourself and your company with APNIC in the case of Australia, and get one of those unique identifier, unique number. You can do Microsoft peering with private ASNs, but it's not recommended. There's some caveats.
Check the documentation site.
Check the documentation,
Limitations.
because your ASN is going to get stripped out and you're going to trip over. Anyhow, moving on. Lots of questions. What is VRF? And how does it relate to ExpressRoute? Well, VRF is VRF stands for Virtual Routing and Forwarding. So think of it as the VLANs for routing. Think of it as a VLAN on layer 2. VRF is the same but on layer 3. So what you do is you have a device, a router.
It's a good way to describe it.
And you tell the router, hang on a minute, so you've got X amount of interfaces on this router with a routing table. What you tell the router is, hang on a minute, I don't want to use one routing table for all these interfaces. I'm going to create virtual routers within that. Virtual router. And I'm going to assign a different routing table 2, to this guy. And now I'm going to split my physical interface into multiple virtual interfaces, and I'm going to connect that up to these virtual routers. So now, when a packet comes in here, it can go to this virtual router with a set of routing table, or can go to that router with a set of another routing table through VLANs.
Cool.
And then be sent out to other things. So it's effectively, a VLAN but for layer 3. Think of it that way.
That's awesome.
Or a virtual machine on Hyper-V. Same thing, right? Well, yeah, in essence, right? How does it relate? Now, Microsoft in all their diagram will always talk about VRFs. And we'll always put on the customer side, you have to create a VRF. Now, this is true, but you can do it with physical routers too. If you're so fancy, when you see a VRF and a VRF, you can have 2 separate routers. There's no problem. If you got the physical capability and the money, you can do that too. But it's always recommended, if you can do it, to go, well, let's use one device for a pair of devices and define VRFs on there, so that if you use, for example, public peering and private peering, Microsoft peering, Microsoft peering and private peering, you can then separate the traffic and go, well, you know what, public peering, Microsoft peering, for my primary and secondary can go to 2 separate VRFs. Although that's not recommended either, but 2 separate VRFs, and my private peering can come to another VRF if I want to, or to a physical device. So that's basically in a nutshell.
And plus MSEEs on our side.
That's right. On the other side, Microsoft, being such a big provider in the same way as other providers, all use VRFs. Why? Because it's economy of scale. You can have X amount of routers running on one.
So many customers
device.
with all of their networks. Of course, you want to keep them all split internally.
That's right.
Obvious
that's
reasons.
Right. That's exactly right. But think of it this way: if I need 5 routers with redundancy, so 10 routers, wouldn't it be great to run it on 2?
Yeah.
That's what VRF is. Done. All right. Direct and indirect providers for ExpressRoute. We're finally getting into the subject of ExpressRoute. We haven't really been doing that. So when you need to connect to Azure through ExpressRoute, you need the help of a provider. There's the bottom line.
Simple as that.
Simple as that. You need somebody to give you a physical wire and say, there you go, there's ExpressRoute, there's your layer 2. Okay? So there's two types of connections that you can do there. You can do an indirect provider first, which is the most common one. Is you basically say, I'm the customer, here's Microsoft. How do I connect the two? I use a third-party provider. Third party, well, the list is long. Megaports, Telstra, XDC, Equinix, etc., etc. And so effectively, that third party here will create the connection, will deliver that connection, that physical connection to you, so that you can go into their exchange, so their network, their core network. So Equinix, it's Cloud Exchange. Megaport, it's MegaX or something called differently, and then they have the connectivity back to Microsoft to say, you know what, Microsoft, we're gonna lease or grab X amount of ports on your edge devices.
So I guess the benefit here too is, imagine this could be in, say, Sydney, right? That could be the customer could be in Brisbane, right? However, if they're using Megaport as a provider, Megaport will have their own direct connection across down to Sydney.
That's
super low latency.
That's right.
And that's also a benefit in itself.
That's exactly right. So what we then see customer do is say, well, say as a customer, I have an existing MPLS network. I then create one connection to there, and suddenly my entire MPLS network uses ExpressRoute to go out to Microsoft, right? So that's in a nutshell, the indirect connection. Now, when we talk about direct, what we mean is effectively, in essence, you strip away this component.
Sorry, providers.
That was nice to meet you.
They sort of still need to be there, provide the physical and...
That's exactly right. So what you're doing effectively in the logical world, you're doing this with a pair of... How you do that and how that physical connection lands into your data center or your premise is still through a provider.
Or you can go to Bunnings, get a shovel and dig your own trench.
Oh yeah, that would work. Or use smoke signals. Works great. 9,600 boats. Yeah. Anyhow, so the physical connection, and this is where people get tripped up on terminology and how it actually works. The physical connection is still delivered to you by a provider. So you'll still have to go to a Telstra or, I don't know, Megaport if they do direct. I think Telstra and... We'll confirm. They'll still deliver that to you, but they'll have a direct connection back to the edge of Microsoft, right? And on top of that, you as a customer still use .1Q or Q-in-Q, like we explained earlier.
Opens up
we're making
opportunities for...
That's right, VLANs. Hello, VLANs, Q&Q versus .1Q. It all makes sense now. It's all tied together. See? I've done this before, haven't I? Anyhow, so that's very, very quickly. Let me check the time. How are we looking? Okay. So this is very quickly the direct versus indirect scenario, the terminology of how do I want to connect?
Yep.
Now this ties in, and you might have seen that on a lot of literature around ExpressRoute, IPVPN and MPLS that we'll spoke about more in detail at the end of the video.
Yep.
But what you can also do is, instead of that wonderful MPLS here, let's go back to that indirect third party. How do you reach this is the question mark, right? How do you end up in a situation where you have a connection, a physical connection in the data center at Equinix, as in, just to name one. How do you reach that as a customer? I've got my office in the CBD. How do I reach Burke Street? Easy. You go to IPVPN. IPVPN is effectively a technology that, MPLS versus IPVPN is effectively using the internet to build your own IPLS network. Think of it this way. It's using the VPN technology to slap on top of the internet to say, I'm going to create my own private network, thank you very much, and it's all going to be automated by a third-party provider. So the third party will drop a router at your place and say, it's an IPVPN router, all you need is one of our internet connection, and it becomes private. And then you reach out to that data center. Or better yet, you can come straight to here, but that's not ExpressRoute anymore, that's VPN at that point. Anyway, so that's in a very quick nutshell IPVPN, but we'll come more in detail if we have the time at the end of the video. Now, ExpressRoute Direct, now that we spoke about indirect and direct connections, there is this new product, service, that has been announced by Microsoft, and I'm sure you're all dying to know what it is, which is called ExpressRoute Direct. ExpressRoute Direct is a way again on connecting to the Microsoft network through ExpressRoute but at a much higher speed than what it used to be. So with ExpressRoute, you could go up to 10 gig, right? Now, with ExpressRoute Direct, you can go up to 100 gig. 100 gig, like, you know, most local networks are not that fast. But anyway, most LANs are not that fast. So you effectively connect directly to Microsoft to a set of ports on the edge network, again using a provider, don't get me wrong, you know, but the logical way is not to use a provider, and it goes up to 100 gigabit potentially. Now the beauty of this is that you can burst that, you can strip up and down that connection and say, you know what, on normal occasion I'm going to use 10 gig of that, but this month I have a big migration, I need to dump 2 petabytes of data into storage, so I'm just going to get it up there for a month, you know, and get 100 gig and flying, and then go back down and say, let's go back to 100 to 10 gig.
Okay.
So easily.
So just a quick recap. So customer could be, say, let's say Brisbane, for example, connecting across state to, say, Sydney, for example. Still there's like cables that they've got to run to plug in somehow. So there's still that connection.
There's still that connection. There's still that physical fiber optic cable that has to come in from somewhere, and that's not provided by Microsoft. That is provided by a third party. So this is where people get tripped between the direct and indirect, thinking that direct, they'll just go, I'm just going to dig a trench with my cable and go to Microsoft directly. No, you still need to go to
Knock on the door. Hey, here's my cable. Come in. Please plug me in.
Go on, do it.
I'll just get it to the ground.
Right, so ExpressRoute Global Reach, yet again a brand new product by Microsoft, service, I should say now. No longer products, we sell services. So,
Global Reach.
I know.
Exciting.
Very exciting. Okay, so let's go blue for that.
In fact, one of my customers is super excited about it.
Oh, really? I can imagine. Say you have Sydney, Azure. Inside of Sydney Azure, you have a virtual network, you have a VNet. Say now you have your Sydney office. Look at this, I'm drawing an office. Sydney. And you have an ExpressRoute in between this.
Cool diagram.
ExpressRoute. Okay, easy. So for now, by now you should know after video 1 and 2 how this is all tied in together, and if it's direct or indirect, it doesn't no longer matter, but you have a connection between a VNet in Azure and your own premises. Okay, now let's expand that a bit. Melbourne. Say you also have a VNet in Melbourne, and you have a second office in Melbourne too. I can't spell Melbourne. There you go. You have an office in Melbourne too. Between that office, you also have an ExpressRoute connection. And of course, because you're one big company, you have a VNet peering. VNet peering, we should do a video about VNet peering because it's a very interesting subject. But in a nutshell, you're connecting 2 VNets together and you make them route
Across regions,
across tenants, across whatever you want.
Yep.
You know, as long as they don't overlap in IP addresses, you can route them together.
Yep.
Now, until today, what will happen to the routing traffic is from here, I can reach this. From here, I can reach that. No problem. From here, can I reach this? No.
You could if you did it yourself.
UDR, but that's not really nice. So you had a problem there. With Global Reach, what Microsoft's done, they connected these two together. So now you have a direct route between your Sydney and your Melbourne office.
But customers could like put their own somehow connection between Sydney and Melbourne, couldn't they?
They could, but
But that would cost quite a bit of money,
Well,
and they
that's-
have to have some sort of device to put in. And
think of it this way, right? If you already have the express route
yep,
on both sides,
yep,
don't go and get a connection there through a third party.
no,
Just connect them together.
Yep.
It's a couple of commands and what
Yep.
you're up and running.
perfect.
And you're using the bandwidth that is on your express route. So potentially 100 gig.
Yep.
Imagine that.
That's
at a
heaps.
fraction of the cost that a third party provider can do it for between Sydney and Melbourne. More so, I'll go even further. Think of it, let's think of it as international market now, right? Say for example, you have an MPLS network, Sydney, Melbourne. MPLS network provided by X, Mr. X. You decide I want offices now in the US. USA. Woohoo. So you're potentially going to do an MPLS network there. Here's the problem, right? What if this provider is not available in the USA? How do you connect the two? Booyah. You go, hang on a minute, I got Azure Sydney here. I got USA, East, West, Central, Mid, Portugal, whatever. Here you go, express route. Beautiful. How good's that? You now suddenly have a global reach for all your networks across the world connected via express route. So it's effectively a third-party provider that is global. So Microsoft is telling you, use our network to communicate throughout. And I'm going global now, but you can see the advantages just locally. To go between Melbourne and Sydney, it would already cost a lot of money anyway.
And here's a stat for you: that new cable that they put in from Virginia to Spain,
Oh,
the
yes.
Maria, is 160 terabits per second.
Wow.
Bandwidth.
That's fast.
That's plenty of
Not
bandwidth.
faster than smoke signals.
So what are you waiting for, customers?
Go on. That's it.
Grab it.
Anything else we need to cover? IPVPN versus, we touched on that. So again, traditional manner, traditional way of doing connectivity between offices. You drop an MPLS tail. What's MPLS? It's effectively an envelope system. Think of it as an extended VLAN, right? It's not right what I'm saying here, but just to go back to basics, when your packets reach the edge router of your MPLS provided by your provider, it's going to get encapsulated into an MPLS packet, right? That as an idea. And so the ID is saying, instead of that VLAN number 2, you get an ID that represents what the edge router on the other site that you're trying to reach is. And the MPLS routing in between is going to get determined by that idea. So effectively, all the routers on the network within the MPLS talk to each other and say, to get from site number 3 to site number 4, this is the route, go. And this is all happening in a private fashion because of those IDs, those tags. It's the wrong terminology, but those tags. So that's MPLS for you, so private. IPVPN is kind of the same principle, whereby you say, I'm going to plug in my
That's an M, by the way,
oh, sorry, yeah.
just in case. Cool. Not N.
Yeah, so it's my
Cool,
right.
go on.
So IPVPN, think of it as this as, I'm going to put my edge router on the internet and get a public IP address. And when my packet leaves my public IP address, it's going to get tagged in the same way. So I want to reach another ID somewhere else. The only difference between the two is that it's going to traverse the internet, so it gets encrypted
Great.
with a VPN encryption level. Done. That's the difference. Easy.
Perfect. Awesome. I think we've covered everything. So Steph, I guess, same as before. How do people get hold of you?
Twitter, Stefan Budo, @StefanBudo. That's probably the best way.
If you're still watching at this time, awesome, fantastic, thank you. Please send us your feedback for the video below down here.
Right there.
Yeah, thank you.